All right. So most of this unit that you're going to see is just going to be doing lots and lots of example problems. And these are the types of problems that will come up on ACT and maybe even like K-Prep. I don't know. So an exponential, that is when you have an x in the exponent. So go to your calculator and go to y equals and type in 1 to the x power and look at the graph. Oh, just kidding. Do 2 to the x power. Yeah.
It's a straight line.
Not 2 to the x power.
Wait, oh, it hurts. Oh, that's kind of cool. 1 to the what?
2 to the x power.
That's kind of cool.
I just wanted you to get an idea of what the graph looks like. Looks something like that. All right. So it exponential, it means it gets higher exponentially fast. It goes like it stays really low and then all of a sudden it shoots way up. And so that's what an exponential equation looks like. So we can solve equations that have x's in the exponents. If you have the same base is this big number, then it's super easy. All you do is you set the exponents equal to each other. So we would set x plus 1 equals to none. And then you just solve that equation. Yep, so if we subtract 1, we get x equals 8. That's it. I mean, it gets a little harder than that, but. So number 2, we both of those have a base of 5. So we can just set the exponents. 4x plus 5 equal to x minus 7. And then if we subtract x, we get 3x plus 5 equals negative 7. And then subtracting 5 gives us 3x equals negative 12. And then dividing by 3, x equals negative 4. Now number 3, notice we have on the left side, we kind of have two different things. We have to combine those before we can set the exponents equal to each other. So if you remember back to our exponent rules, if I have x squared times x to the 5th, what would you tell me that is? X to the 7th. Remember, you add exponents. The same thing applies here. 3 to the x times 3 to the x plus 2, you add the exponents. So this would be 3 to the x plus 2 equals 3 to the 5x minus 1. Then I can set my exponents equal to each other. So that would be 2x plus 2 equals 5x minus 1. So then if we subtract 2x, we get 2 equals 3x minus 1. And then adding 1 to both sides, 3 equals 3x. So x equals what? 1. Number 4, see if you can combine these so that we only have one base 10 on each side. So this would be 10 to the 5th power, because negative 4 plus 9 is 5. And then this would be 10 to the 3x minus 7 power. So then we would have 5 equals 3x minus 7. Adding 7 gives us 12 equals 3x. And so x equals 4. Good. So whenever we have bases that are not the same, that's when it can be a little bit more complicated. So on this left side, I have a base of 6. My goal is to make this side also have a base of 6. So think about it for a second. How can I turn this 36 into 6 to some power? Close. 6 squared. 6 squared is 36. So now those have the same base. So this may require a little bit of, if you don't know your multiplication facts, this might require a little of extra guess and check. But 2x minus 10 equals 2. And if I add 10, we get 2x equals 12. So x equals 6. You can do the same thing for number 6. We have an 8 that we would want to have a base of 2. 2 cubed, good. 2 cubed is 8. So then we would have x minus 7 equals 3. So x equals 10. Number 7. I've got a base of 7, and I want the other one to have a base of 7. Think back to your exponent rules. We learned about negative exponents. And if you remember, if this was a negative 1, I could turn that into a fraction, 1 over 7 to the first. Well, 7 to the first is just 7. Now, if this had 7 to the negative 2 power, that would be 1 over 49. 7 to the third power would be 1 over 512. No, 343. No, it's not one of those. 643. Okay. So then we have 4x plus 11 equals negative 1. So 4x equals negative 12. and x equals -3. All right, number 8. We have a 2, a what? Yes. 2 to the 5th power is 32. If you didn't know that, just test it out in your calculator. 2 to the 3rd power, 2 to the 4th, 2 to the 5th, until you get it. So then we have 5 equals 2x minus 9. And if we add 9, we get 14 equals 2x. And then we divide by 2, we get x equals 7. Thank you. Good. So, see, we'll be doing a lot of like equation type stuff. And this whole unit is going to be like equation stuff. So some of you may really prefer this. All right. Now this next one, I'm frozen on there. There we go. That says 27 there. You can't really see that. 27. Oh, no. I'll show you. So the 27, we want to turn into a base of 3. And we do know that it's 3 cubed. But we also have that 2x plus 6 there. I don't know. I wrote that really bad. Sorry. So that would be 3 to the 3rd power. And then we have 2x plus 6. You think back to your exponent rules.
So you multiply 3 and 2x.
When you have like exponents on exponents, that's the power rule. That was 6.1. You multiply. So this would be 3 to the 6x plus 18 equals 3 to the 2x. And then we can set 6x plus 18 equal to 2x. If we subtract 6x, we get 18 equals -4x. And then if we divide by -4, we get x equals -4.5. Now, if you want to check your answer, if you're like, that's a decimal, I don't know if that's right, then go back to your original problem, 27, and then type in to the 2, well, actually, let's do this. Let's do x store as -4.5. What? Why doesn't it let me do that? Oh, -4.5 stores x. Sorry, I did it backwards. All right. Then we can type in 27 to the 2x plus 6. And 3 to the 2x. It doesn't really matter what you get as long as they're the same. And those are essentially both what? 0, not 5.1, because that E. All right. Number 10. So our goal is to have the same base. What is 16 with a base of 4? 4 squared. Yeah. But I do expect On these questions, you can't just give me an answer. That tells me you photomathed it. Or you copied off somebody. What's photomath? So glad you don't know.
Oh, no. How does that work?
All right. Now over here, we have 4 to the 2x minus 6.
So you multiply what's in the parentheses all the way out.
The 2. It's kind of, yeah, we just basically distribute it. So this would be x plus 2 equals 2x minus 6. And then if we subtract x, y'all working ahead, just hold on. And then you add 6 to both sides to get x equals 8. All right, what about number 11?
Would you do 5 cubed and 5 squared?
Yeah, I can't just turn 25. I can't give 25 a power to be 125. So we actually have to change both of them. Both of them can have a base of 5. So this is like 5 cubed to the x power and 5 squared. So this would be 5 to the 3x equals 5 squared. So then we say, all right, well, 3x equals 2. And dividing by 3 gives us x equals 2/3. If it's a repeating decimal, like any of the thirds, leave it as a fraction. The only way a decimal is okay is if it's like a decimal that stops. You know, I wouldn't even, if it has like 7 I would do like 0.5 or 0.25. Other than that, write it as a fraction. Because look, if I do 125 to the 0.67 power, it's not going to be exactly right. 125 to the 2/3 power is 25. And when we get to some later in this unit, I will make you round to at least 4 decimal places, because just a few decimal places can really throw off your answer. All right. So number 12, I can't give 8 a power of anything to get 16. So can't be 4, because 4 doesn't, I can't have 4 with the power to get 8. It's 2. So this would be 2 cubed. No, 2 to the 4th, sorry. And 2 cubed.
Are you more likely going to get a fraction or decimal on all the ones like this? Because I got another fraction.
It's possible. So this would be 2 to the 12x equals 2 to the 3x plus 6. So remember, we multiply. And we have 12x equals 3x plus 6. This would be 9x equals 6. And then if you divide by 9, that's also 2/3. Number 13. Same thing. We're going to have to change both of them. This would be 2 squared and 2 cubed. This one right here spins about all the time.
This one right here is spin.
Yeah. All right, so this would be 2 to the 6x equals 2 to the 3x minus 3. Does anybody not know how to get those two steps? I don't care to kind of go back through them. Just speak up if you don't know. All right, then we have 6x equals 3x minus 3. Subtracting 3x gives me 3x equals negative 3. And so x equals negative 1. All right, these two, they're going to have a base of 2 again. Yep. This is 2 cubed. 8 is 2 cubed. And 32 is 2 to the 5th. So then I kind of just need to distribute this exponent. I get 6x minus 3 as one of the exponents and 10x plus 5 as the other. Subtracting 6x gives me negative 3 equals 4x plus 5. And then subtracting 5, negative 8 equals 4x. And then dividing by 4, x equals negative 2. Any questions? All right, now these last two, we're going to have to do some combining before we get started. So this 4 has an imaginary 1 exponent. So this is really 4 to the 4x plus 1 power. And we can make this have a base of 4. You could have changed them both to 2, I guess. But this is 4 cubed equals 4 to the 4x plus 1.
Say like on the final, if you did just do that to 2, would you be wrong?
You would, if you made this, is that 2 to the 6th, 2 to the 6 and 2 squared, you would get the same answer at the end, regardless. So 3 equals 4x plus 1. And then if we subtract 1, we get 2 equals 4x. And so x equals 1/2. Or you could put 0.5. Here we have 4 to the 2x power. How can I make this one have a base of 4? 4 to the negative 2nd power. Kind of like we had the 1 over 7. That was 7 to the negative 1. Well, 4 squared is 16. So if we want 1 over 16, that needs to be a negative 2. And these have the same bases. So this would be 4 to the 2x minus 2 equals 4 to the 6x plus 18. So 2x minus 2 equals 6x plus 18. So I subtracted 2x from both sides. And then if I subtract 18, we get negative 20 equals 4x. And then dividing by 4, x equals negative 5.